Hi. My mic is on. Hello, Copenhagen. Woo! Thank you very much. Thank you. We are LiveJS. You may have guessed. Yeah, it was all there, right there. We are a collective of musicians, visual artists, lighting artists, hardware hackers. There are actually a couple more that are here today. There's only 3 of us. And there's one thing that we all have in common, and that is creating technology and using web technology for all the things that you just saw. So let me introduce. We have Martin on the lights over here. We have got Matt on the music buttons. That's it. And I have got control of the projector, which is great. I love that. Everything you just saw is actually all just powered with HTML, CSS, and JavaScript. We don't tend to use much else. We've got some hardware up here, but that is it. Everything can be run in a browser or something like native, like Electron. We're also going to be playing a show. That's what we do. We play live shows. We're going to be playing a show for you tomorrow evening or tomorrow at the end of the day. So please stick around for that, because that's essentially you're going to get a much better taste of the sort of stuff that we do. And everybody knows that you can't play a show without music.
And I just so happen to have made an application that is entirely web-based and makes music.
Oh, that's amazing.
So it's perfect for what you're talking about. What are the chances we'll be on the same stage?
I know.
Oh. So, yeah, this app is all of the good stuff, plus web audio, WebMIDI, and it runs in Electron for a few technical reasons, but essentially it could run in just any kind of browser that's not IE. I think it would just about run an Edge. So, here is the application. Oh yes, thanks, bring my camera in. So you can see that I have some things on the screen that are pretty and colored, but what they represent is different sounds that I can trigger at any moment. So over here you'll see I have some buttons that line up with these images on my screen. So what you're seeing on my computer is actually just a visual representation of these hardware controllers I have. So I can just play sounds, or I can trigger perfectly in time with the beat. And then I can loop it. Thank you.
Just get carried away.
And so all of the music that I was just playing before, well, I set all these sounds up in advance, but the music itself, every event I was playing, either live or as a loop that I'd created live in front of you. So you may have noticed the song we played now was quite, well, different to the one earlier today. If you were checking precisely, it was very different. Same sounds, same kind of overall, but that's the thing. Every time I play something different. And that was the thing that I found very difficult to do with other software, and that's what inspired me to make my own software. And the reason I made it in JavaScript and web audio and HTML and CSS instead of using something more traditional like C++, was because I have no idea how to do C++, and I'm a web developer. Typical. Thank you. So, most of you probably are quite familiar with CSS, HTML, and JavaScript. But how many people here have actually done things with web audio itself? All right, that's good, yeah. So you probably don't need to, those people that put their hand up probably don't need to actually listen to much of this. But I'm going to just, for those people who have never done anything with web audio, I'm going to answer a few important questions like, why is there a web audio API? And how I like to think about it is, before we had Canvas and SVG on the web, we could only make things that were rectangle, square, or some sort of one single curved edge, or maybe all four curved edges. Maybe one of the curved edges was bigger than the other curved edges, but that was like all the geometry you could do, unless you wanted to bring in something like Flash. So the same thing applies without the web audio API. You're stuck with pre-rendering things in other software. So with images, it was Photoshop. And with audio, it could be something like Pro Tools or whatever tool you're using. But with web audio, we can now have this amazing power that we have with other types of technologies like Canvas and SVG, but for audio as well. So now we can create amazing interactive soundscapes for games and other applications, or we can make a full-on music application in the browser. So it's pretty cool. And this is, I guess, the simplest possible example of how you'd make some sound with web audio. So if I run this, it's a sine wave. This here is a slightly more complicated example. It sounds like that. And so you can see exactly how this code works, right? It's quite complicated and impossible to follow. So I'm going to try and give you a bit of a metaphor that only about 5% of the people in this audience will understand. That is not web audio. That is absolutely not web audio. There is no make it sound good button in web audio. You don't have someone who's sat down and figured out the perfect way for you to craft a rocking slow rock, a sweet disco beat. Was that March? So you don't have any of that. You've got to wire it all up yourself. So it's a lot more like modular synthesis. Anyone familiar with modular synthesis here? Yeah, awesome. So web audio is exactly like that. You have a bunch of small little modules which you can plug together and route to make all sorts of interesting sounds that you could never imagine. And while that sounds like a lot of responsibility, with that responsibility comes great power. And really shiny, cool stuff. Well, it's less shiny in web audio, but... So, with that in mind, I have taken the web audio code and I've restructured it to make it look more like real-life objects that everyone here is familiar with, which is modular synthesis. So, you can see here, he's putting modules into a rack. That's like the audio context. So when I create an audio context, I'm saying, give me a box that I can put like things in together. So the first thing I'm going to put in this box is a big volume knob. So I can turn it all the way down to almost 0, because if it was any louder, you'd all go deaf. That's the thing about web audio, is that it's generating sounds that are normalized to 1. So 1 is the maximum amount of movement a speaker can make inside of a box. -1, +1. So if I was to do that, the sound guy would hate me, but you'd also go deaf. So the next thing I've got is an oscillator. And an oscillator is a device that is constantly moving between -1 and +1 at a fixed rate. So this particular oscillator has its knob set to 220, which is 220 cycles per second. So it's going to be moving like this 220 times a second. And it's square wave, which means that it's going to move quickly between its two states instead of moving nice as a sine wave. And I've got that oscillator connected directly to the speakers through this volume control. So I'll show you what it sounds like when I play this. So probably no huge surprises there. That's what an oscillator sounds like when you pipe it into a speaker. But if instead we unplug it from the speakers, and it's not going to make a loud pop, luckily, and we plug it in to the filter, which is another unit I've got in my rack, and I plug that filter into the output, now you can hear that it's a bit muffled. And if I adjust the filter parameter, you can hear it getting a bit brighter. Uh, 220. If I set it to 220, you've actually just got a sine wave again because it's filtered out all the harmonics. So that's how a filter works. Next up, I've got an LFO. And an LFO is actually just an oscillator that's running really slowly. But I can connect, not only can I connect oscillators to the speakers directly, I can also connect them to other parameters. So for example, we have the frequency knob on the filter. I can connect it directly up to that. I can plug it straight into that parameter. And then we'll hear something like this. Oops. I pushed undo quickly. That's weird. Oh, I deleted the line. Okay, there we go. So now you can hear it filtering like this. And if I can speed it up. Slow it right down. I can change the amplitude. What else can I do? I can make it a high pass. We have a HIG pass. And then I can get my other LFO, which is exactly the same, except that it's connected to the oscillator's frequency. And then I can just go all out and connect one LFO to the other LFO's frequency. Anyway, the possibilities are endless, and if you have a lot of time, you can get sucked down a rabbit hole into amazing sound exploratory something. Clever word. So that's great and neat and everything, but for me making an audio application, I want hands-on control. And so that's where these come in. These are called MIDI controllers. They're very much like that, except that they're shaped in a grid instead. But they work pretty much exactly the same way. So I can very easily access these from the browser using the WebMIDI API. And so if I just close this, and then I run this, you'll see messages being logged out. So this is every single key press on this device. And I've just got an event handler in here that's logging out to the console. But if I instead hook it up to my code from before, we'll hear some music. No, we won't. I changed this last minute. I don't know. Anyway, that's what you get. But anyway, it totally would have worked if... What do you think, Ruth? Is that cool? Is that what you want?
That is very cool. That is very cool. And it's great that you're making music, because I need music.
Really?
Yeah, I need to analyze the music for my own visuals. So it's great that you're making it. So thank you very much.
Oh, no problem.
What am I? Yeah. And he did loads of live demos, which I'm not doing.
That's a bad idea.
No. So yeah, I need music because obviously I'm making visuals to this music. So I analyze this sound to create my visuals. I'm the VJ, also known as visual jockey, also known as an AV artist, audio visual artist. I don't actually create the sounds, I just use the sounds. I'm going to need a llama.
Oh, yeah.
I know.
Gosh. Thanks for reminding me.
How are you getting on over there? It's so smooth, isn't it?
All right. Yep.
The transition. Who remembers this?
Winner. It really whips the llama's
Good,
ass.
yes. Brilliant. That was totally on cue.
Winner. It really whips the llama.
It's so good. Yeah, always get the DJ to do your sounds for you. Greatest MP3 player of all time, don't you agree, right? Lightweight, you could just chuck MP3s in. Yeah, okay, not quite as portable as what we have now, but who cares? For those of you that are too young to remember, this is quite an old piece of just MP3 playing software. But this wasn't the best bit, the fact that it used to play noise. No, the best bit was this. It had a visualization engine, right? So you could plug in visualizations to your MP3 player, and they would go in time to the music. I used to sit and watch this for hours when I was a student, probably the most influential piece of software for any VJ of my generation. But the thing is, once we got the audio API and some of the newer, shinier things that we got with CSS and JavaScript, I started wondering a few years ago whether I could recreate this in a browser. Funnily enough, you can. So just a quick demonstration of just a few things that you can do. To create visuals, we do need to analyze the sound. This is one part of the audio API which Matt didn't cover. The majority of the audio API is creating and modifying sounds, but there is an analyzer node. This gives you back frequency data. So as we saw with the different frequencies that you can generate with an oscillator, you can actually analyze these different frequencies. They're the different tones in sound, right? So when you analyze these, you get the amplitude. Thank you, amplitude value at any given time. I always say velocity at that thing, and it's completely different. You get the amplitude value, so you're basically getting a value back for any of these tones within a sound. And then you can use that data to create anything that you want. It's really cool, it's just numbers. So this is a really, really simple example. This is just some DOM elements. All I've done is just chuck some I elements in my DOM, and I'm just changing the height of them depending on what data I'm getting back. This is analyzing my voice right now. So actually, I'm piping in the mic, because I can pipe that into the audio API. And this is just, if I go quiet, they all drop down. Then if I go loud again, they all come up. And that's a very, very, very simple example of how to do it.
Louder!
Louder. Oh, dear. So that's it. The code is a little bit simpler than Matt's, but not very much. It is still quite low level. We just create an analyzer node, and then we can use the array that we get back to do that. The thing is that when you start playing with this, you can actually start to play with some of the more fun things that we have in browsers now. I particularly like playing with new CSS features, blend modes and filters I quite like. This is exactly the same example that you just saw. I just exchanged the I elements out for image elements, and then just chuck some CSS filters on, and then use the data to sort of change the filters. It's quite loud at the moment. Oh, I see. There you go. I quite like going from loud.
Yeah, dynamic.
Loud to quiet. So you can start playing around with it. It's a really nice creative thing to do. Another new feature, which I think is really interesting to start using this data for, is custom properties. I'm sure you're all aware of what custom properties are, but I will just reiterate for those of you that might not be. If you've used any CSS preprocessors before, Sass, less, stylus, and you've used CSS variables within that or variables within that, this is basically the same idea in spec. You just specify the top of your code and the root element with a dash, whatever you want to call your custom property, and then set whatever value you want that to be. The really interesting thing with custom properties is you can access them with JavaScript. So I'm analyzing this data with JavaScript. I can pipe that real time now into my CSS. That's pretty cool. That's JavaScript all up in your CSS rather than the other way around. So here at the bottom of this code, and I won't dwell on it because it's the end of the day, we've all had a long one, document.document element.star set property. I'm accessing that root, that level declaration that I've put in the top in my root. And I can change CSS properties with that. So I can just pipe the data that I'm getting back from the audio analyzing straight into my CSS. It's a great thing to play with. It's a great thing, like I said, to get creative with. I did this quite a lot. I did things with DOM. I did things with SVGs. I was just basically sandboxing ideas for visuals. There's a whole bunch of stuff on CodePen that I did last year for Codevember. And it was great for the creativity for my software. And it's very, very interesting when you start building your own software. Matt is a great deal ahead of me as far as years, so is Martin. You'll see his software in a minute. Mine actually doesn't have an interface. Funnily enough, after I did all this experimentation, I have actually now switched to Canvas, but that's a little secret. It's difficult writing software on your own. I have actually left the interface, like the GUI, to last, which is a very different way to what I'm used to working. And it's actually really, really nice that now I have the crew around me because I can actually bounce off of them. So thank you very much, guys. It's really good. I've been concentrating on things like data structure. How do I structure all this stuff that I'm mixing in and out? I spend a lot of time on audio analysis. The audio analysis we get back from the audio API isn't perfect when you actually want to do visuals. So I spent a lot of time refactoring that and just getting all those things right. And controlling the visuals as well. Matt mentioned controlling his music with MIDI. I control my visuals with MIDI too. I have a MIDI controller up here. I'm on my 5th iteration of MIDI controller. So every single time you get a new one, you have to figure out which button is going to do which thing. And this is quite time-consuming. A little word about MIDI. And again, we're going to play some sound. This isn't MIDI. It's good. Don't get me wrong. I'm just going to let it run for a minute. Yeah, I love it. Try not to dance. So I can't help it. We didn't rehearse this. What you heard, those noises, that is actually digital audio. And the file itself might have been in MIDI format, but MIDI is actually just the data. It came around in the early 80s. There was a rise in popularity of electronic instruments in the 70s. And they were taking them into recording studios, and they were finding all the recording equipment was electronic, all these instruments were electronic. They had no way to talk to each other. So a bunch of industry experts and music instrument manufacturers got together and they were like, wouldn't it be really nice if we had a protocol for all this equipment to talk to each other? And that's when MIDI came about. First specification came out in 1983. General MIDI 1. There is now General MIDI 2. It's just a bit bigger, a bit shinier, a bit like the jump from HTML4 to HTML5. But it is essentially just data, as we've seen with Matt's example for MIDI. When he presses buttons, what we get with the WebMIDI API is just numbers. And we can just listen for those numbers, and we can just use it as an event and trigger whatever we want on it. Just to give you an example, were you going to show it again?
I was going to, except I have the wrong... Oh, I need to run it.
Is your audio example now working?
That one.
So as he's pressing buttons, those numbers, that's what you get back with the audio API. WebMIDI API, sorry. Cool. Smooth. Just to give you a good example, this is a MIDI instrument. I'm sure you've all seen all of these. This is a keyboard. You press the keys, it plays noise. There is onboard audio in this piece of equipment. That's the difference between something like this and this, which is what we use. This is a controller. It has no onboard audio. If you press a button, it doesn't make a sound. You have to program it to make a sound, and you would probably do that on your computer with a piece of software. So we're all using these, and we all press buttons, we get a number, and we create and we get it to trigger whatever we want. A very, very simple demo of what's going on with my software, and I'm hoping that my one demo, which is working, yes, it is, great. This is my MIDI controller. I'm going to go over to the camera over here. We got camera? Yeah, we've got camera. So this is my MIDI controller right here. I've got one slider down here which does my main mixing. Basically, the software has two screens, and I sort of do a crossfade like this. It's a little bit more complicated in the actual software. But if I go from one side to the other, you can go from one screen to the other. And then all the other buttons are set up to change what's being shown. I've got different effects going on all the different sliders. And that's my simple demo. Thank you, Matt. Thank you. It's too simple. That was well-timed applause, because as I was saying, we all use MIDI, and I believe, Martin, you use MIDI as well.
I do. Right. So I was going to talk to you a bit about how all this light show stuff works. This is actually a 2-year-old project by now, which I did for effect for a talk I gave at JSConf EU, and but it kind of evolved over time. Before I got into web development, like 10 years ago or something, I did work as a stage and lighting technician. So this kind of like the project is a fusion of the two professions I learned so far. If you've seen and kind of gave that away already, it's actually more like light show CSS because the whole thing is basically just one big CSS file that I can control with a MIDI controller, which sounds weird, but I get to explain it. So this is a bit of this CSS file. It just defines some colors, brightness, animations, stuff like that. We will get to that later. So I have everything of that running in my browser. So it's this one large CSS file that is actually interpreted by the style engine of Chrome. And I have all these light fixtures, like these lamps up top here, are all represented by single DOM nodes. And I can just apply styles to that, and yeah, I can control it just by setting element classes to a parent element, which is done with this launchpad controller. So I just figured I will just use a single class name for each and every button. So they are like A1, A2, A3, and so on. And I can configure them to be either like triggers, or as long as I press, the class gets added to the element, and if I release, it gets removed, or switches like press on, press off. So how does all that work? The first thing is HTML. This is pretty easy. I have like a device. I have a device group that is used to logically structure these devices, these device elements. They have like a channel attribute and a type, and nothing to worry about. It's basically just browsers will simply accept that as HTML, and they can already apply styles to that. So that's the HTML. I can just drop it into my page and start styling this with CSS. Now, CSS, you already saw that. I have like completely made up properties like brightness and stuff like that, but I can just use it, and I get the browser to compute these values for me. And then we add some JS. So it's basically just a loop that runs every 33 milliseconds, and it will get, for these devices, get the computed style that contains already interpolated values for transitions and animations, which is exactly what I want. And then I can extract from this current style my color value, my brightness value, and hand that over to a different part of the software that will handle the communication with the devices. This involves a WebSocket, several USB ports, serial ports, a node process, stuff like that. I won't go into detail here. Final thing is the protocol that is used to control professional lighting hardware, and this is quite amazing. It's an industry standard since like 30, 40 years or something like that. I don't know. Do you?
I don't know when DMX came out, no.
Okay. But yeah, it's pretty old, and it's the only protocol that is used in professional lighting equipment. So whatever you buy, you can control it with this protocol. So let's have another look at this CSS. Maybe some of you wondered why that doesn't really work, and no, it doesn't. The thing is, you can't just make up CSS properties. Other than the HTML parser, the CSS parser will just say, I don't know it. It doesn't show up in the computed style. So what we can do to fix this is add 2 dashes to the front. So with that, we convert them to custom properties, and those show up in the computed style, so I can just get there. The other problem that we face is that custom properties don't really work together with transitions and animations. I don't even know if they should. I feel it's a bug, but I have no insight into that. So what we can do instead is we just use placeholder properties, fallbacks, basically. So we use the left property instead of brightness. We use the right property instead of pan. And we have an infinite amount, not infinite, but we have a huge amount of possible CSS properties that can be animated. So we can just use them instead and need to figure that out later. So what happens in total is we take this one big style sheet, and this is done using a rework parser. Then there's a tiny AST transform function that will just add the 2 dashes and introduce these fallback properties. Then the CSS is injected into the page, at which point it will already apply to these device elements that are already there. And then I can use my animation frame, use get computed style to get to values. I can remap, for instance, left to brightness in order to send that over to my DMX interfaces. As a result, I can just for instance, press this button here and have these lights turn on. Or maybe like this, something more beautiful. Whatever. So, oh, you see how they're jumping around. This actually it's running in a different tab, and this is the throttling of the request animation frame loops happening there. Normally it would be smooth. So. Now, if we prepare a show, we usually receive a few weeks in advance. I receive papers that will tell me what equipment is there, how is it connected, and all sorts of things like that. But it's really hard to imagine how that will look if I write the CSS like this. And so. We think of professional productions like the light show for a Beyoncé concert. This is usually planned 6 to 12 months in advance. And they neither have access to the real equipment, so they use stuff like pre-show visualization software, which is basically a really fancy 3D rendering of what the light show will look like in the real stage. So there are several vendors, but there's basically just one industry standard software there. Licenses are around 10,000 euros, something like that. Then I wrote them, explained what I'm doing, and wanted to have a license, and they basically just laughed at me. So what I did instead was building my own, which is running right here. So what you're seeing on the right-hand side of the screen is real-time 3D visualization of this menu here. And if I just bit more brightness, yeah. So you can see this. So, and what I have to the left-hand side is actually the live editors. I think I can just scale them up a little bit. All right. Okay. So, I don't know. Maybe we can just add some style here, just so you see that it is indeed live editing. So this should. Oh wait. I believe we need to be a bit more specific. Yeah. So I'm currently there's a bug that I can't use important. Maybe that's not a bug. I don't know. But yeah, that's pretty much what I wanted to show. The software I call DMX Pen. Oh wait, it's a bit darker. Yeah, I guess you already saw that. So
that's amazing, Martin. That's brilliant. Well done. I'm guessing you wrote in that you can't use important. Well done. Well done. I'm proud of you for that.
It's a feature.
Yeah, it's a feature, not a bug. Matt.
All right. So, before we let you get back to business as usual, that's really unfair. I'm sorry, I shouldn't have said that. I'm going to really get everyone's blood pumping. You're all going to stand up if you want. It's up to you. But trust me, it'll be worth it. It won't be anything bad. So stand up, please.
You were serious?
Oh, yeah, cool. So, I would open this by saying I left my drum kit at home, so I need your legs. But that could sound really weird. So instead, I'll just say, can I all get you to stomp on the count of 3? And you'll see what I'm going to do with that. So, ready? 1, 2, 3. Oh yeah, that looks good. Just turn that back up. And we'll give it a bit more. Yeah, that's nice. And how about some clapping on the count of 3? 1, 2, 3. And who knows what a hi-hat sounds like? That's pretty good. So this one's going to be very important that we get perfectly in time. So I'm going to go 1, 2, 3. Tss. Ready? Whoop. I jumped the gun. 1, 2, 3. A bit louder, maybe. Oh, it sounds so good. And lastly, how about we get a ColdFront or something like that from... Who's got the loudest voice in the room? Who can yell into this microphone from all the way at the back? Actually, that would be really cool. Can someone from the back yell out ColdFront? Not yet. Okay, ready?
That was really good. That was really good.
On 3. 1, 2, 3. Yeah. Good one, DJ Matt. What? Okay. You can dance now. You're standing up. Yeah. So, I've never had someone at a tech conference dance before. Like, actually, this would just make my day. If you could just pretend to dance. You don't have to actually dance. Ready? Here we go. Yeah.
Thank you very, very much, ColdFront. We have been LiveJS.